Hello everybody. For this chapter we're going to be covering try-catch blocks and how to use them to make your code more robust. And we're going to talk about the two types of exceptions, unchecked and checked. And then we're also going to look at how to handle multiple exceptions. And postponing errors by using throws, and also automatic cleanup using try with resources. So let's get started. Often in programs, we can do things, and depending on the input that we have into our methods, it can cause our programs to crash. And that's a bad thing. We don't want programs to crash. We want to be able to handle the bad input and take corrective actions to fix that or to shunt it to some other part of the program. So we're going to look at using try and catch blocks to handle what we'd call dangerous method calls, or method calls that can cause the program to crash if they don't get the correct input. So like I said, with some method calls being dangerous, that means that they can produce a runtime error, and we don't want them to produce a runtime error. So an example of a method that is safe, i.e. not dangerous, is printline. There is no way for the printline method to generate a runtime error. You can have a compile error, but not a runtime error. On the flip side, here's an example of a method that could generate a runtime error, or what we would call dangerous. And you might have seen this in a previous homework assignment, where if you tried to read in a number from the console but typed in a string instead, that doesn't equate to a number, then it would have generated a runtime error. Now, obviously, it's not ideal to have this exist in our code. We want to make sure that our program is robust, but at the same time easy to use. And so how do we do that? Well, we can use exception handling. More specifically, we surround the method call with a try block and insert a catch block immediately after the try block. And it looks, we'll see an example of what it looks like on the next slides. But before we use the try and catch blocks, we need to understand the syntax. So let's take a look at it. We have a try block followed by a catch block. The try block contains the code that may throw an exception. Below it, we have the catch block, and it's the section of the code that will catch the exception or the error that is thrown. The JVM looks for a catch block that will catch the thrown exception object. That is, it looks for a matching catch block. If it finds one, it executes it and continues below the catch block. If there's no matching catch block, the program will crash. So here's an example of a try and catch block code fragment. Here you see we are trying to parse this integer user entry right here. Right? Oh, let me get my right color. All right, we're trying to parse user entry and then store it in quantity. If user entry is not an integer number or an integer string that can be converted to an integer, it's going to throw a number format exception right here. And so this block will catch that number format exception. And it will print out this message right here saying invalid quantity entered. Must be a whole number. So if you tried entering a decimal, it would do the same thing, right? Because a float is not an integer. So with this example, the question is how do you know what type of exception parseInt will throw? Well, we could run the program without the try catch and force the error to see what the compiler says. Or, better yet, we could just check the documentation. The Java docs will tell you what type of exception is being thrown, right? So here you can see parseInt, right, throws number format exception. Notice here, catch, number format exception. Okay, so again, documentation is critical. Being able to read and understand the APIs that are published is instrumental to you being a good developer. Now, there's lots of different types of exceptions that can be thrown, and we're not going to cover all of them, but let's take a closer look at the number format exception. The number format exception is well named because it is thrown when a number's format is inappropriate. So here you can read the Java docs description of the exception, right? Attempted to convert a string of one numeric types, but that string doesn't have the appropriate format. All right. More specifically, though, the exception is thrown by one of the parse methods, such as integer parse int, long parse long, double parse double, so on and so forth, when there's an attempt to convert a string to a number and the string's characters don't form a valid number. Right? So each of these examples here would throw the number format exception, parse int right here, because this is not an integer, right? And parse double because this m on the end of it makes this whole thing not a double. And of course, it's always better to see things in code. So let's go ahead and take a look at an example. So here we have our lovely line plot example. And all it does is takes in 2 coordinates as strings, converts them to integers, and then prints some output accordingly. Here you can see our plot segment. We take in an x and y integer, and we print out some values, and then we set the new values we passed into the old values, which are part of the class. We come down into the main method. Okay, we've got our scanner. Obviously, we've got our line plot object because we need to have access to these items, right? So we've got this line now. We have 2 strings to hold our x and y inputs, and then we have 2 integers to pass in to store our strings as integers once we parse them. Then we send a message to the user that just says, hey, enter your x and y coordinates or Q to quit. We read the x string, and if it does not equal Q, we will execute this loop. We then read in the y string, and then we try to parse them into our x and y coordinates. And then we plot them using the line plot segment, right? Here's our plot segment. Here's what we're calling it. And then we just repeat the loop here. We're going to ask the user to enter the x, y. We enter the x. If it's not Q, it'll continue through the loop. If it's Q, we'll end. All right. So what's the problem with this? Well, the problem is right here, right? And if either one of these is not an integer, it's going to crash. So if we run the program, let's test that out. If I enter 1 and 2, hey, okay, that works fine. If I enter 2 and 4, that works fine. You can see how it took our 1 and 2, made it our old 1 and 2, and now we're going to 2, 4. If I do 17, 18, right? So on and so forth. I can do this all day. But the second I enter something that's not allowed, like I'm going to enter TJ or YJ and 30.2, look what happens. It crashes. That's ugly. So how do we fix that? Well, we're going to surround these blocks right here with a try-catch block. So let's take a look what that looks like. Here's our line plot final version, and you can see here we have our try block and then we have our catch block. The catch is going to catch the number format exception that was thrown. All right, so again, let's run this and generate a number format exception, right? If we put in 3.2 and 2.3, all right, you see it right here, number format exception, number format exception. All right, and so we catch the format exception and we say, hey, whatever you entered wasn't right, and then that's it, and then it prompts you to enter it again. Notice how we have the line plot or the plot segment method inside the try block. Why do we do that? Well, the thing about the try block is if this method call right here throws an error or throws an exception, it's going to skip everything else in the try block. It's immediately going to go from here down to here and then execute this. So we don't want it to try to plot the line segment if we have an error with either one of our x, y. So if x is fine and y is wrong, well, it's still going to skip it and make us enter it again. So that's why the plot segment method is inside the try block with these. Even though this doesn't necessarily generate an error, we don't want it to be executed if either two of these throw an exception, right? So those are the kind of things you need to think about when working with your tries and catches, is how do you handle the flow of your program when you encounter an error. So let's go ahead and take this for a run and see what it looks like. All right, inner coordinates, 1 and 2. All right, that works. 2 and 4. All right, JK and 3 or 0.32 says, hey, you got an integer, integer space integer. Oh, okay, 5566. Whoops. Apparently I'm hitting the Alt key and not the space. There we go. All right, so there you have it. It works. If we enter 3.32, 6, all right, same thing. Still fails. All right, 6, 3.2, doesn't work. Okay, so that is try and catch blocks in a nutshell.